Hello everyone. In various fields, we need information in the numerical figures. Each figure of this kind is called an observation. The collection of all observation is called data. So today, let us discuss something more related to this in our lesson, data handling. Types of graphical representation. They are telechart or frequency chart, pictograph, bar graph, double bar graph, histogram, and pie chart. First one is frequency distribution. Let us take one example. Suppose we make survey of 20 families of a locality and find out the number of children in each family. Let the observation be as shown. State the frequency of each observation. Solution. Arranging the data in ascending order, we get the observation as shown. We find that 1 occurs 6 times, 2 occurs 10 times, and 3 occurs 4 times. We say that the frequency of families having one child is 6. The frequency of families having 2 children is 10, and the frequency of families having 3 children is 4. Thus, the frequency distribution table of the above data may be represented as given in the next slide. The next subtopic is pictograph. A pictograph represents data using pictures or symbols, as shown. Next one is a bar graph. A bar graph is a graph that displays the frequency or numerical distribution of a categorical variable showing values for each bar next to each other for easy comparison. Bar graph example. In June 2005, the US Department of Transportation reported the following data by observing 1,700 motorcyclists nationwide at randomly selected roadway location. So proper helmet is 731, insufficient helmet is 153, and no helmet is 816. So the total is 1700. Thus, the bar graph of the above data may be represented as shown. Double bar graph. Double bar graph example. The table shows the number of pets owned by students in two classes. Now, let us represent the information in double bar graph. Thus, the double bar graph of the previous slide data may be represented as given below. Histogram. A histogram is a bar graph that shows the frequency of data within equal intervals. There is no space between the bars in a histogram. Example, the table below shows the number of hours students watch TV in 1 week. Make a histogram of the following data. Histogram example. Thus, the histogram of the previous slide data may be represented as given below. Circle graph or pie chart. A circle graph represents data in a circular form. A circle graph shows the relationship between a whole and its parts. It is divided into sectors. Each sector visually represents an item in a data set to match the amount of the item as a percentage or fraction of the total data set. How to draw a pie chart? Step 1. Calculate the angle of each sector using the formula. Step 2. Draw a circle using a pair of compasses. Step 3. Use a protractor to draw the angle for each sector. Step 4. Label the pie chart and all its sectors. How to calculate an angle of a pie chart? To calculate the angle of each sector, we have to use the formula. Angle of sector is equal to frequency of data upon total frequency multiplied by 360 degrees. So, the total angles should add up to 360 degrees. Pie chart example. In a school, there are 750 students in year 1. 420 students in year 2 and 630 students in year 3. Draw a circle graph to represent the numbers of students in these groups. Solution. Total number of students is equal to 750 plus 420 plus 630 is equal to 1800. Year 1 size of angle is equal to 750 divided by 1800 multiplied by 360 is equal to 150 degrees. Year 2 size of angle is equal to 420 divided by 1800 multiplied by 360 is equal to 84 degrees. Year 3 size of angle is equal to 630 divided by 1800 multiplied by 360 is equal to 126 degrees. Thus, the pie chart of the previous slide data may be represented as given below. Now let us see the meaning of probability. Probability is used to describe random or chances of events to occur. Every day we are faced with probability statements involving the words. What is the likelihood that X will occur? Event and probability. An event is some specified result that may or may not occur when an experiment is performed. For example, in an experiment of tossing a coin once, the coin landing with heads facing up is an event, since it may or may not occur. The probability of an event is a measure of the likelihood of its occurrence. The equal likelihood model. This model applies when the possible outcomes of an experiment are equally likely to occur. Suppose there are n equally likely possible outcomes from an experiment. Then the probability that a specified event equals the number of ways f that the event can occur divided by the total number n of possible outcomes. The probability is given by f divided by n. F is the number of ways event can occur and n is the total number of possible outcomes. In other words, in a situation where several different outcomes are possible, we define the probability for any particular outcomes as a fraction of the proportion. Probability example. A jar contains 1000 marbles. 800 are black and 200 are red. What is the probability of drawing a black marble out of the jar? Solution. Here, 800 is the number of possible outcomes f. The total number of possible outcomes is 1000 n. Thus, the probability is P black is equal to 800 black marbles upon 1000 total marbles, which is equal to 8 divided by 10. So the answer is 0.8. And probability of red is equal to 200 red marbles divided by 1000 total marbles is equal to 2 divided by 10, which is equal to 0.2. The probability of drawing a black marble is much higher than the probability of you picking a red marble because there are more black marbles in the jar. So this was all about our lesson data handling. Learning about data handling is very important as it is used for organizing our data properly. It is used in libraries to keep record of books. Doctors keep records of patients. Meteorologists take records of the weather. Astrologists record the movement of the stars, etc. So learning about them is very important. Thank you, students.